In the context of continuously rising animal protein prices in China, traditional supplies of fish meal and soybean meal are facing increasing pressure from climate change, stricter fishing quotas, intense global competition, and massive domestic demand. Large-scale livestock farms are confronting an extremely difficult challenge: how to maintain high production levels while controlling feed costs, and at the same time, transitioning toward a more sustainable long-term production model. In this very context, a solution that may seem simple but has proven its real-world effectiveness over many years is black soldier fly larvae. It is gradually becoming one of the strategic directions that many companies and large farms in China are paying close attention to and investing in strongly. It is no coincidence that they are called the cleaners of the organic world. These tiny larvae are capable of consuming almost all types of organic waste that humans typically consider as trash, from leftover kitchen food, spoiled vegetables and fruits, fruit peels, soybean pulp, to livestock and poultry manure, and even materials that have already begun to decompose and produce unpleasant odors. Even more remarkable is that within just a little over 10 days, they can process tons of waste per day and transform materials that would otherwise need to be landfilled, incinerated, or cause serious water pollution into a highly nutritious and high-value biomass. When analyzing the nutritional composition of black soldier fly larvae, they present a profile that is highly suitable for modern livestock production. Their nutritional value typically reaches about 40 to 60% crude protein, depending on the larval feed source, and 25 to 40% fat. Particularly notable is lauric acid, which has strong natural antibacterial properties, helping to suppress certain harmful gut bacteria. In addition, they contain about 5 to 10% chitin, a component that was once underestimated, but has now been proven to stimulate immunity, balance the gut microbiota, and enhance natural disease resistance. Especially the high levels of calcium and phosphorus provide excellent support for bone development, strong eggshells, firm shrimp shells, and thick crab carapaces. Although their overall protein content is not as high as that of premium quality fish meal, black soldier fly larvae offer outstanding advantages, including better digestibility for many livestock species, significantly higher sustainability, and extremely flexible scalability. Their production does not require large land areas, consumes very little fresh water, and does not compete with human food production. Most importantly, the production cycle is short, only about 2 to 3 weeks from egg to harvest, allowing rapid scaling when market demand increases, making them suitable for both small and medium farms, as well as large industrial systems. When black soldier fly larvae are included in poultry diets, from broilers and laying hens to ducks, geese, and quail, the results are very positive and in many cases even superior under good management conditions. When partially replacing protein from soybean meal or fish meal at moderate levels, typically 5 to 30% depending on formulation and growth stage, animals continue to grow well and in many cases achieve faster weight gain and improved feed conversion efficiency. Many farms report clearly improved feed conversion ratio, better gut health thanks to lauric acid and chitin. Final product quality is also evaluated positively. Meat is more flavorful, firmer, and has better color. Especially in laying hens, eggs often have thicker shells, darker yolks, higher nutritional value, and more uniform size. Practical use is quite flexible, depending on the form of the ingredient. With fresh larvae, with moisture content of 60 to 70%, farmers usually feed them directly or mix them into daily feed at a ratio of 10 to 30%. A common formulation for laying hens in the production phase may include 45 to 50% ground corn, 15 to 20% rice bran or wheat, 20 to 30% fresh larvae, 8 to 12% soybean meal to supplement amino acids if needed, and 1 to 2% premix. For broilers, many farms apply a ratio of 15 to 25% fresh or dried larvae, reporting improvements in average daily gain of 5 to 12% and a reduction in feed conversion ratio by 0.1 to 0.3 points. For dried larvae, with moisture content reduced to about 8 to 15%, feed mixing becomes much more convenient, especially for industrial pellet production or for commercial distribution to large farms. In this form, larvae are commonly used to replace 10 to 25% of fish meal or soybean meal in formulations. A typical formula may include 50 to 55% corn, 18 to 22% dried larval meal, 10% rice bran, 5 to 8% soybean meal, 2 to 4% vegetable oil, and 1 to 2% premix. This approach allows long-term storage, easier transportation, and still maintains good production performance. However, more is not always better. When the proportion of larvae exceeds reasonable levels, chitin, although beneficial at low levels, can reduce protein and energy digestibility in some sensitive poultry types, especially high-producing laying strains or fast-growing broilers. Therefore, based on practical farm experience, it is recommended to formulate feeds carefully, closely combining larvae with energy-rich ingredients such as corn, wheat, and rice bran, while supplementing certain limiting amino acids, especially lysine and methionine, if necessary. When implemented correctly, many farms have reported feed cost reductions of 10 to 20%, and in some cases significantly higher profit per animal due to more stable flock health and better product quality. For aquaculture, the overall picture is quite similar but with distinct characteristics. For omnivorous species such as tilapia, pangasius, carp, sea bass, shrimp, crab, and some eel species, black soldier fly larvae are often used to replace a large portion of fish meal, sometimes up to 50 to 75% depending on formulation and species. At appropriate replacement levels, most growth performance indicators are well maintained, and in some cases growth is faster, feed conversion ratio is lower, and survival rates are higher. Notably, the immune system of aquatic species is often significantly improved due to the stimulating effects of chitin and antibacterial compounds from the fat fraction. However, if inclusion levels are too high without proper formulation adjustments, chitin can interfere with digestion in some sensitive species, especially those with short digestive systems, or those requiring high levels of long-chain polyunsaturated fatty acids, such as eicosapentaenoic acid and docosahexaenoic acid, such as white-leg shrimp or marine fish. Therefore, farmers often combine larvae with fish oil, vegetable oil, or processed soybean meal to rebalance the fatty acid profile. When done properly, feed costs can be reduced by 20 to 30%, while significantly reducing pressure on natural fish meal resources, which are becoming increasingly scarce and expensive. From a broader perspective, the greatest value of black soldier fly larvae lies in their profound circular economy significance. They transform waste into valuable feed, reduce dependence on other expensive ingredients, and contribute to lowering greenhouse gas emissions and pollution from livestock production and processing. In China, with its massive livestock production scale and enormous volumes of organic waste, the application potential is extremely large. Numerous farms and companies in Guangdong, Zhejiang, Shandong, Henan, and other regions have implemented industrial-scale black soldier fly larval farming systems, utilizing organic waste from food processing plants. Many projects also receive support from circular economy programs and national carbon reduction targets. Of course, no solution is perfect from the beginning. Ingredient quality depends heavily on the larvae feed input. Initial investment costs for farming systems can be relatively high for small operators, and time is needed to optimize nutritional formulations for each specific target species. However, with the rapidly increasing pace of research and practical application today, along with support from fermentation technologies, thermal processing, probiotic supplementation, and enzyme additions, the development pathway of black soldier fly larvae is becoming increasingly broad and highly promising. With its massive livestock production scale and abundant waste resources, China has a clear advantage to become one of the world's leading countries in applying this solution. From small and medium farms to large corporations, black soldier fly larvae not only help reduce costs, but also contribute to building a greener and more sustainable livestock industry, fully aligned with national development directions for the coming decades.